Hello everyone, this is Mayuk Mazumdar and I'm back with another exciting session. So let's proceed.
In my last session, I've introduced you all to file handling. Now, in this session, I'll be giving you a more deeper insight into file handling. So, there are 4 different ways of opening a file. Now, what are they? They are basically of the 4 categories. R, which stands for read mode, A stands for append mode, W stands for write mode, and X stands for create mode. So when we open a file in read mode, the read mode is the default value for opening a file, and when we open a file in read mode, it we can read the contents of the file, and if the file doesn't exist, it returns an error. When we open a file in append mode, it is used for appending more new additional contents to the file, and if a file doesn't exist, it then creates that file. When you open a file in write mode, it's used for basically writing fresh content into a file. If a file is existing, then it overrides the contents of the file, and if not, then it will create a new file. And when you open a file with the mode X, that's used for defines for create mode, so it basically creates the specified file and returns an error if the file is already existing. In addition to the above mentioned modes, you can specify if the file should be handled as binary or text mode. So T stands for text mode, and this is the default value or the default mode, and B stands for binary mode. Now let me show you. I'm back with my obsession Bella Ciao, and I'll be opening a file named as Bella Ciao, and let's print that variable file. So when I print that variable file, what I find out that it's an object of type text-IO wrapper, and its name is Bella Ciao, and it has been opened in mode R, as I said, the default mode, and the encoding is UTF-8. Now let's open the file in RT mode and find out what happens. When I do so, again I'll get an object of type text-IO wrapper whose name is Bella Ciao, and the mode is RT as I have specified explicitly. So till now we can read a file. Now what I have to do is we have to read the contents of the file. So how to do so? Let me show you. So when I open the file and I print the file.read, that is the from the file object I'll be calling the read method. So when I do so, what it returns is it gives me the content of the file. So in order to read the content of a file, we just simply have to create an object of that type file, and we have to simply execute that file.read command. Now I don't want to read the entire content of the file, I just want to read the first 5 characters or the first 50 characters of the file. So maybe reading the first 5 characters. When I do so, see, I'll be getting the first 5 characters, and over here characters itself is an indication of the each letter. Now when I want to read the first 50 or say first 100 characters of the file, when I do so, simply I have to place that 100 index as an index variable in that function, and it returns the first 100 characters of the file. Now okay, I don't want to read the entire file at once. I don't also want this character headache in my life. So but I want to read each line of the file. How can I do so? I can simply use the function .readline. So function file object .readline will return me each line of the function. So as I printed the first line, so it's printed once, so I'll be printing the first line. Now say let me print the first 3 lines of the file. So when I do so, the first 3 line gets printed. Now for iterating over each line of the file, we can simply iterate over the entire line count of the file, and we can simply print file.readline. So till now we have seen how to open a file and how to read the contents of the file in various modes, and now we'll be introducing it to how to close a file. It's always a good practice to close a file, because in the end of the day, whenever we keep a file opened for in the entire big execution flow of a program, so it hampers the execution time of the program. If we keep multiple files open and without closing, then the runtime may vary. So it's always a good practice to close the file when you're done with it. Now let me show you how to close the file. As I am opening the file, I'm reading the content of the file, and then simply using the .close function, I'll be closing the file object as well. So it's always good to close. Now, when I want to write to an existing file, there are the two modes in which I can write to an existing file. First is the append mode. When we write write a file in an append mode, what happens? It appends the content at the end of the file. It happens the whatever content I've added at the end of the file. So in my file, you see the last line is the last line of the lyrics of the song Bella Ciao. Now I'll be adding the content that I've added more content to the file. I'll be writing this line. Now I am opening the file in append mode, and when I do so, see, let me go back to the file. Yes, it shows the line I have added more content to the file. Now I have opened the file, I have written, and then I've closed it. Now I'll again like to add more content, and then I'd like to read the content of the file programmatically as well. So when I do so, you get to see that this line have been added twice, once in my previous run and once in this run, that I have added more content to the file. So that was about how to write content to a file. And when I open a file in write mode, so what happens is that it overrides the existing content of the file, and it starts writing the new content that I feed the file with. Now we aim to creating a new file. Suppose it's at one case in your program execution, you may need to create a new file and write contents to it. So how can you do so? Programmatically, that can be easily done. We can create new file in various mode: in X mode for creating, in A mode for appending, in W mode for writing. Whenever we open a file in one of these three modes, if a file is non-existent, it creates a new file. So in this example, I'll be creating a new file. I'll be opening a file in write mode, and then I'll be writing the content hello professor to it. When I run, so I get to see that my sample.txt is created with the content hello professor to it that I have just added, which was non-existent till now. Now I would like to delete a file. So for deleting a file, let me introduce you to one more thing, that is import OS. So maybe this is the first time you are seeing in my lesson this import OS. So what is import OS doing? Import is a keyword, is basically used for calling or importing the packages, pre-existing packages. Now what is a package? A package is nothing but a collection of classes with some predefined function which have been defined for our better use. We can use them to reduce our workload. Instead, we may have to define the functionality of these functions manually. But thanks to developers around the globe, they have defined packages to help us to reduce the pain in coding. A more detailed session about packages are sure to be coming in the coming days. But for now, till now, you just get that a package is basically a collection of classes which have pre-existing classes and functions that have been defined for our better use case. Now I'm importing this package OS which performs OS related operations. Now what am I doing? I'm checking that whether this sample.txt file exists or not. If it exists, then I am os.remove. With this os.remove, I am removing the file. And if it not, then it will simply give a print statement that the file does not exist. But now I see that my sample.txt is existent. Now I'll be just running the script, and I get to see that sample.txt is vanished. Boom. Now if I run the script again, I'll get to see that os.path exists returns a false, and as a result, in the code section, the pointer of the code goes to else section, and it prints that the file does not exist. So this was all about how file handling can be done in Python. It's quite an easy task and will be very required in our day-to-day coding. Now let me come to the next section of today's session, that's the errors and exceptions. Until now, error messages haven't been more than mentioned, but you have tried out the example, you have probably seen some. There are at least two distinguishable kind of errors. One is the syntax error, another is the exception. Now, what is syntax error? Syntax errors are also known as parsing errors, are perhaps the most common kind of complaint you get while you are still learning Python. So, how to do so? Let me go to my Python console, and when I'm in my Python console, let me manually do a syntax error. So maybe while true, I should have given a colon, but I am printing that created a syntax error. So when I do so, I get a syntax error saying invalid syntax. So I should have given a colon. Let me now show you how this will be made true in syntax. So when I run this code snippet, say printing is an error. Oh, what I've done. The actual syntax will be while true printing created a syntax error. Now see, until I close it manually, it's an infinite loop which runs on executing. So I'm stopping and the process got finished with execution 0. Now the next is exception. So even if a statement or exception is syntactically correct, it may cause an error when an attempt is made to execute it. Errors detected during execution are called exceptions and are not unconditionally fatal. Most exceptions are not handled by programs. So let me go to my Python console. Now if I try to divide 100 by 0, so that's an exception, 0 by division error. Now if I want to use a variable named as var without defining it, then what I get a name error, that is the name var is not defined. Now if I want to add a string with a variable, so what it gives me, it says that that's my bad. Now it says that type error, that must be string, not integer, because we can't add an integer along with a string. Now the next section is handling exception. It is possible to write programs that handle selected exceptions. So let us look at the following example. Using try and catch exception, using try and except, we can always handle exceptions. Try and except block, we can always handle exceptions. So over here, what I'm doing, so let me now exit from my Python console. So in this case, what I'm doing, I'm accepting a number and then I'm creating a exception manually. So let me show you how it is being done. So when I run, so I'll be asked to enter a number. So now if I enter a number, it breaks. Now the second use case, that when I do so and it has been, now it shows me that caused due to an exception as I have printed, and the exception is invalid literal for int with base 10. So it was asking me to input to integer a number. So now let me give something string as an input. When I do so, it again shows me the same exception, that it expected an integer, but I have given something else, that is a space or maybe a string. But the program is not running into exception because I have handled that. And how have I handled? I have handled them using the try and except block. The try statement works as follows, that is, first the try clause, that is the statement between the try and except keyword, that is this two, x equal to int of input, please enter a number, it accepts a number, and then whenever I give a valid number, maybe 60, then it breaks it, then the program exits with an exit code 0. Now if no exception occurs, the except clause is skipped and the execution of the try statement is finished, as you got to see here. And if an exception occurs during the execution of the try clause, the rest of the clause is skipped. That is, if suppose over here an exception occurs, it's not breaking, it comes into the exception clause, and it's print that cause due to an exception as I have given in the within the braces, and the exception was invalid literal for int with base 10. So this is how we can handle exception. Now we can also raise exceptions. The raise statement allows the programmer to force a specified exception to occur. When we will be digging more into coding, we will definitely get to see these things, how to raise an exception. Now let me go back to my Python terminal, and when I do so I'll be raising an exception. So let me, using the keyword raise, I'm raising a name error exception, and in return I'm saying hi average student. So when I print enter, it raises a name error, and as the value argument it accepts this high average student that I've passed to it. So in this case, in this way I have. So at many use cases, business use cases, you may find it required that whenever a certain criteria does not match, you may need to raise an exception, and that can be easily raised by using this raise keyword. Now there is a cleanup action. The try statement has another optional clause which is intended to define cleanup actions that must be executed under all circumstances. Now, if a finally clause is present, the finally clause will execute as the last task before the try statement completes. So, over here, let me add the finally clause. Finally, I am printing code executed successfully. Let me run it and show you, then you will get to have a better picture. So let's print a number 16. Now what happens is, you get to see initially when finally block was not there, whenever I enter a number, it was accepting the number and it was executing this break statement, and it was going out of the loop, or it was going out of the execution flow. But now when I've inserted this finally block, so it prints that the code executed successfully, and it prints after this break statement happens. So even after the break statement, I have the developer have the chance that even if it's in try it's acceptable in the try block, or even if it falls into an exception in the except block, however a final statement is definitely bound to be executed. So this is how we can clean up our actions. So this was all about file handling and errors and exceptions in Python. Thank you. Have a great day.